All right, so today we are going to finish page 5 of chapter 18 notes with this video here. And it starts out by saying that any carbocation can react in a Friedel-Crafts reaction. So what we saw on page 3 and 4 were alkyl halides that formed carbocations, and then the benzene ring attacked the carbocation. In this case, we're going to form a carbocation a different way, and then the same type of reaction is going to occur. So what you should be able to do is look at this and see that there is a carbocation that has been formed in previous chapters with this and that. And so go ahead and pause this for a second and try to predict how these two species would react to form a carbocation. Pause. Unpause. Great. So what you've probably figured out is that alkenes are somewhat basic. This is sulfuric acid, a really strong acid. So this pi bond can go grab a proton from sulfuric acid, and when it does that, it's going to form a carbocation. It's going to add the hydrogen in this position, which generates the tertiary carbocation, the most stable type of carbocation that is not somehow conjugated. So that carbocation is now going to undergo a standard type of Friedel-Crafts reaction that we saw with the other types of conditions. So the pi bond is going to add to that. That's going to make this species be added to this ring. So that would give a tert-butyl group added to the ring. There's a hydrogen in that position as well. And then we're going to have the carbocation there. Why is the carbocation there? Well, if you think about these two positions, both of them had 1, 2, 3, 4 bonds. This carbon has 1, 2, 3, 4 bonds. Here, this hydrogen's still here, but it now only has 1, 2, 3 bonds. So if you do your formal charge calculations, you'll see that there should be a positive charge there. Then we're going to have to reform that aromaticity. We're going to do that with any base that's available. So although we don't have a super strong base around, this is a really reactive species, so the conjugate base of sulfuric acid is going to be strong enough to deprotonate this and reform the aromaticity. So it's going to come in, grab that proton. The electrons in this carbon-hydrogen bond are going to go down and form the new pi bond to generate our product. Benzene ring that is monosubstituted. So that is another way to do Friedel-Crafts reactions without those other types of additives like aluminum 3 chloride, etc.